Hello everyone, Assalamu alaikum. This is Muhammad Huzaifa Wasim. Welcome back to our channel 𝐂𝐡𝐚𝐧𝐧𝐞𝐥. This video is part 1 of lecture 3. So let's first we see our objective which we are going to cover in part 1, part 2 and part 3 of lecture 3.
Measure of dispersion, which is range, interquartile range, variance, standard deviation, coefficient of variation, measure of shape, skewness and kurtosis. Dispersion. Dispersion measures the extent to which the items vary from some central value. It may be noted that the measure of dispersion measure only the degree, the amount of variation, but not the direction of variation. Okay, actually the technique that are used to measure the extent of variation or the deviation of each value in the data set from a measure of central tendency, usually the mean or median. Such statistical technique are called measure of dispersion or variation. Okay, the various measure of central value give us one single figure that represent the entire data, but the average alone cannot adequately describe a set of observations unless all the observations are the same. It is necessary to describe the variability or dispersion of the observation. Actually, the measure of central tendency describes that the major part of values in the data set appear to concentrate around a central value called average, with the remaining value scattered or spread on either side of that value. But these measures do not reveal how these values are dispersed or spread on each side of the central value. So the dispersion of values is indicated by the extent to which these values tend to spread over an interval rather than cluster closely around on an average. Types of measure of dispersion. There are two main types of dispersion methods in statistics, which are absolute measure of dispersion and relative measure of dispersion. Absolute measure of dispersion. An absolute measure of dispersion contains the same unit as the original data set. Absolute dispersion method express the variations in terms of the average of deviation of observation like standard or means deviation. It include range, standard deviation, quartile deviation and so on. Actually, absolute measures are described by a number or value to represent the amount of variation or differences among values in the data set. Okay, the types of absolute measures of dispersion are, actually we will be studying four types of absolute measure of dispersion, which is number 1 range, number 2 mean absolute deviation, about their mean and about their median, number 3 standard deviation, number 4 variance and quartile deviations and so on. Okay, relative measure of dispersion. Relative measure of dispersion are used to compare the distribution of two or more data sets. This measure compares value without units. Common relative dispersion method include. It means that when you have to compare two data sets, then you have to calculate the coefficient of deviation. Okay, according to their number 1 coefficient of range, Then you have to compare the data according to their range. Then you have to calculate the coefficient of range. Then you have to compare the data with the help of variance. Then you have to calculate coefficient of variation, coefficient of standard deviation, coefficient of quartile deviation, and their coefficient of mean deviation. Why is dispersion important in statistics? The measure of dispersion are important as it helps in understanding how much our data is spread or variation around a central value. It means that a small dispersion among values in the data set indicate that data are clustered closely around the mean. The mean is therefore considered representative of the data. Conversely, a large dispersion among values in the data set indicate that the mean is not reliable. It is not representative of the data. Okay, so dispersion is the state of getting dispersed or spread. Statistical dispersion means the extent to which a numerical data is likely to vary about an average value. In other words, dispersion helps to understand the distribution of the data. In this graph, you can see that two or more sets of the data may have the same arithmetic mean values but differ in variation. The graph C, the largest variation, largest spreadness as compared to the graph A. Examine the two histograms below. Both groups have the same mean weight, but the values of group A are more spread out compared to the values in group B. Okay, it means that group A has more variation as compared to the group B. So both groups have an average weight of 267, but the weight of the group A are more variable. Okay, graph A has more fluctuation, more variation, as more spreadness as compared to the histogram of group B. This section will examine five measures of dispersion: range, variance, standard deviation, and the coefficient of variation. Computing measure of dispersion and relative position. Number one is range. So what is range? A measure of variation defined to be the difference between the largest and the lowest value in the data set. So range is equal to the maximum value minus minimum value in the data set. How you have to calculate the coefficient of range? What is the meaning of coefficient of range? It means that you have to calculate the value in the form of percentage. The relative measure of range called the coefficient of range, and it is denoted by C dot R, which is equal to the maximum value in the given data set minus minimum value divided by maximum plus minimum value. Okay, when you have to compare the two data set according to their range, then you have to calculate the coefficient of range. It is quite useful in cases where the purpose is only to find out the extent of extreme variation, such as industry, quality control, temperature, rainfall, and so on. But the calculation of range is based on only two values, largest and the smallest value in the data set, and fail to take account of any other observation. Okay? Of variability example. Suppose that you have to compare two data sets, two teams. Height of players of two teams in inches are as follows: team 1 and team 2. So you can see that team 1 and team 2 have same mean and same median and same mode. So how are you going to compare them? You can see that team 1 range is equal to the 6 inch and team 2 range is equal to the 17 inches. So team 1 variation is less and team B variation, team 2 variation has more. It means that team 1 variation is less as compared to the team B. Team B have more variation. Okay. A major drawback of the range is that it uses only two extreme values, ignores all the intermediate values, and provides no information on the dispersion of the values between the smallest and the largest observation. So, on the other hand, variance uses all the values and provide information on the dispersion of the intermediate values. So we consider we can use it variance. Mean deviation or mean absolute deviation. The mean deviation from the mean is a measure of spread. It tells you how far the values deviate from the mean. Okay, it tells you how far the values deviate from the mean. Remember that the deviation is always a positive number. So you can calculate the mean deviation from the mean as follows. Calculate the mean of the given data. First, you have to calculate the mean of the given data. After the second step, calculate the deviation for each value, which is xi minus x bar. Calculate the mean of those deviation. Actually, the mean of deviation of individual values in the data set from their actual mean is always equal to 0. So such a measure 0 would be useless as an indicator of variation. So this problem can be solved into two ways. Ignore the sign of the deviation by taking their absolute value. Okay students, ignore the sign of the deviation by taking their absolute value, or square the deviation because the square of a negative number is positive. So you can calculate the mean deviation or mean absolute deviation with the help of two formulas, which is grouped and ungrouped formula. You can see that, and coefficient of mean deviation about mean is equal to the mean deviation about mean then divided by mean multiplied by 100. When you have to compare two data according to their mean absolute deviation, then you have to calculate the coefficient of mean deviation about mean. Let's see an example. You have to give in xi values, which is ungrouped data. Okay, what does it means? How you have to calculate it? You know that mean deviation about their mean for ungrouped data is equal to the summation of absolute their deviation and then divided by total number of observation. Why we have to take in absolute? Because the sum of deviation is always equal to 0. So ignore the sign of the deviation by taking their absolute values. First you have to calculate the mean. Sum of all observation then divided by total number of the observation, which is equal to the 7. So your mean is 7 and the total number of the observation is 6. So first you have to make a column for xi minus x bar. Xi values, which is 6, 10, 5, 4, 9 and 8. X bar is equal to the 7. So you can see that the sum of deviation is equals to 0 when we have we will take an absolute. So you can see that the sum of deviation is equal to the 12. So your answer is 12 divided by 6 is equals to 2. It means that on average each observation is 2 units away from the mean. Okay. Another example. Find mean deviation about the mean for the following data. Okay, you have to give in values with corresponding their frequencies. It means that you have to give in group data, and then you have to calculate the mean deviation about the mean for the group data. So how can you calculate it? This is the formula for mean deviation about mean for the group data. So for calculating the mean deviation about mean for group data, first you have to calculate the arithmetic mean. So the arithmetic mean is equal to the summation of frequency multiplied by xi, then divided by summation of fi. So first you have to make a column for frequency multiplied by xi, and then take a summation for this column, which is equal to the 300, and the sum of frequency is equal to the 40. So your arithmetic mean answer is 7.5. After that, you have to make a column for absolute deviation. What is absolute deviation? Subtract xi values by their mean and then take an absolute for this value. Your xi value is 2, then minus 7.5, and then take an absolute, which is equal to the 5.5. 5 xi values, then subtract their mean 7.5, and then take an absolute, which is equal to the 2.5. After that, multiply by this column by their frequency. Okay, multiply by this column by their frequency, and then take a summation for this column, which is equal to the 92. Put this value in the above formula for mean deviation about their mean. So the 92 divided by 40 is equal to the 2.3. This is your mean deviation about mean answer. Now let's see another example for calculate the mean deviation about their mean. For group data, you have to give in class intervals and corresponding their frequencies. Okay, you have to give in class boundaries because there is no gap between upper class interval and their lower class interval, which is called class boundaries. Okay, so you have to give in class boundaries with corresponding their frequencies. So you have to you have to calculate the mean deviation about their mean for group data. So what is your formula? Mean deviation about mean is equal to the summation of frequency multiplied by absolute deviation and then divided by sum of frequency. So sum of frequency is equal to the 14th. You can see in this table. First you have to calculate the arithmetic mean. So arithmetic mean is equal to the summation of fi multiplied by xi, then divided by summation of fi. So first you have to make a column for midpoint of the class interval or class boundaries. After that, class mark or midpoint multiply by their frequencies, and then take a summation for this column, which is equal to the 92. Then 92 divided by 14 is equal to the arithmetic mean, which is equal to the 6.57. Okay, after that make next column, which is absolute deviation. Xi values, which is 3, minus mean value, which is equal to the 6.57, and then take an absolute for this value, which is equal to the positive 3.57. Then next value 5 minus 6.57, and then take an absolute for this value, which is 1.57. After that, multiply by this column by their frequencies, and then take a summation for this column, which is equal to the 23.72. Then 23.72 divided by sum of frequency, which is equal to the 1.69. So this is your mean deviation about mean for group data. Deviation about the median. So the mean deviation from the median is a measure of spread. It tells you how far the values deviate from the median. Okay, so this is you have to give in two formulas for group data and ungrouped data. And coefficient of mean deviation about median is equal to the mean deviation about median, then divided by median, multiplied by 100. Let's see another example for calculating the mean deviation about their median. calculate the mean deviation about median for the following data. You have to give in class interval with corresponding their frequencies. Okay, so this is your group data. How can you calculate the mean deviation about median? So this is your formula. Mean deviation about median. Now put median value in the given formula, which is equal to the median is equal to the 28 and sum of frequency is equal to the 50. So first you have to make a column for frequency multiplied by their absolute deviation according to their median. So first you have to take a midpoint for the class interval. First you have to make a column for midpoint of the class interval, lower class interval plus upper class interval, then divided by 2, which is equal to the xi values. After that you have to make a next column for xi minus median and their absolute deviation. It means that xi values minus their median value and then take an absolute for this value, which is equal to the 23. Then next value is 15 minus 28, which is your median, and then take an absolute for this value, which is 13. After that multiply by this column by their frequency. Okay, multiply by this column with their frequency and then take a summation for this column, which is equal to the 508. So the summation for this column is 508, then divided by 50 is equals to the 10.16. It means that your mean deviation about their median is equal to the 10.16. This is your mean deviation about median. Let's see another example. Example number 2. Find the mean deviation about the median for the following data. You have to give in a series which are unarranged. Okay, and then you have to calculate the mean deviation about median for the given series. So this is your unarranged data. Okay, then you have to calculate the mean deviation about the median with the help of ungrouped data formula. So first you have to calculate the median for the given series. Arrange the given series in ascending order. Okay, arranging the data in ascending order. After arranging the data in ascending order, divide the data into two equal parts. So 5 observation on the left hand side and the 5 observation of the right hand side. So 9 is your median. And another method is calculate the median with the help of formula, which is n plus 1 divided by 2th value. Okay, n plus 1 then divided by 2th value, which is n is equals to the 11 plus 1, which is equals to the 12. Then 12 divided by 2 is equals to the 6th observation in the given series. So what is 6th observation in the given series? Which is 9. So 9 is your median. Now your median answer is 9. After calculating the median value, you have to calculate the mean deviation about median, which is equals to the sum of absolute deviation of their median then divided by total number of observation. So your total number of observation is equals to 11. After that you have to calculate the sum of absolute deviation according to their median. So how can you calculate it? You know that xi is your observation and m is your median value. So first you have to make a column for absolute deviation according to their median, subtract each value by their median and then take an absolute for this value and then take a summation for this column, which is equals to the 58. Okay, and then divide it by total number of the observation, which is 11. Then your answer is 5.27. Next topic is quartiles, quartile deviation and coefficient of quartile deviation. So what is quartile? Quartiles meaning divide the data into four equal parts. Okay. The quartile deviation is a simple way to estimate the spread of a distribution about a measure of its central tendency, usually the mean. So it gives you an idea about the range within which the central 50% of your sample data lies. Consequently, based on the quartile deviation, the coefficient of quartile deviation can be defined, which makes it easy to compare the spread of two or more different distributions. Okay, with the help of quartiles, you have to compare the spread of two or more different distributions. You can see in this picture. The limitation or disadvantage of the range can partially be overcome by using another measure of variation, which measure the spread over the middle half of the values in the data set, so as to minimize the influence of outlier or extreme value in the calculation of range. Since a large number of values in the data set lie in the central part of the frequency distribution, therefore it is necessary to study the interquartile range, also called mid-spread. To compute this value, the entire data set is divided into four parts, each of which contain 25% of the observed value. The quartiles are the highest value in each of these four parts. The interquartile range is a measure of dispersion or spread of values in the data set between the third quartile and the first quartile. In other words, the interquartile range or deviation is the range for the middle 50% of the data. Okay, quartile range and coefficient of quartile deviation. So the interquartile range of a data set is the difference between the third quartile and the first quartile. Okay, it covers 50% of the spreadness. It is the range for the middle 50% of the data. It covers, it overcomes the sensitivity to extreme data value. So quartile range is cover 50% spreadness of the given data. And then you can calculate semi-interquartile range, quartile deviation and coefficient of quartile deviation with the help of following formulas. Let's see an example. Example number 1. A group of Brigham Young University students collected data on the speed of vehicles traveling through a construction zone on a state highway, where the posted speed was 25 miles per hour. The recorded speed of 14th randomly selected vehicles is given below. You have to give in 14 vehicles data, and then you have to calculate and interpret the quartiles for the speed in the construction zone. Okay, First you have to calculate first quartile, second quartile and third quartile, and with the help of quartiles you have to pass the comment for the vehicle's speeds. Okay, so how can you calculate the first, second and third quartile? First you have to arrange the data in ascending order. The data is already in ascending order. So your second step is calculate the median or second quartile for the given data. So how can you calculate the median or second quartile for the given series? Your given series have 14 observations. So divide the data into two equal parts. 7 observations are on the left hand side and 7 observations on the right hand side, and then take an average of the two middle term, which is 32 and 33. So this is your median. 32 plus 33 then divided by 2 is equals to the 32.5. So this is your median. Okay, after calculating the median you have to calculate the first quartile and third quartile. Okay, so how can you calculate the first and third quartile value? Your for first quartile value you have to take first 7 observation, which is 20 up to 32, and for third quartile you have to take last 7 observation, which is 33 up to 40. Okay, 20 up to 32 for first quartile, 33 plus up to 40 for third quartile. For first quartile you have to select 7 values, divide the data into two equal parts. 3 observations are on the left hand side, 3 observations are on the right hand side. So 28 is your first quartile. Similarly, same procedure for third quartile. Divide the series into two equal parts. 3 observations are on the left hand side and 3 observations are on the right hand side, and 38 is your third quartile value. Q1 answer is 28 and the Q3 answer is 38. So how can you pass the comment with the help of quartiles? Let's see. 25% speed for first quartile. First quartile meaning 25% of the observation below of the first quartile and 75% of the observation above of the first quartile. So 25% of the speed are less than or equal to the first quartile. So it means that 28 miles per hour and 75% of the speed are greater than 28 miles per hour, because your first quartile answer is 28. So it means that 28 miles per hour values are less than first quartile, and 75% of the speed are greater than 28 miles per hour. Similarly, same procedure for median. What is your median answer, which is equals to the 32.5? Your median answer is 32.5. So median is actually divide the data into two equal parts. 50% are above, 50% are below. So it means that 50% of the speed are less than or equal to the 32.5 miles per hour, and 50% of the speed are greater than or equal to 32.5 miles per hour. Same as third quartile. What is third quartile? Third quartile meaning 75% of the data above than below than third quartile, and 25% of the values are above than third quartile value. So it means that your third quartile answer is 38 miles per hour. It means that 75% of the speed are less than or equal to third quartiles, and 25% of the speed are greater than 38 miles per hour. So this is your comments. The interquartile range, denoted IQR, is the range of the middle 50% of the observation in the data set. It controls the 50% spreadness of the given data set, interquartile range. So Actually, interquartile range is the difference between the first quartile and the third quartile and is found using the formula. Interquartile range is equal to the Q3 minus Q1. Okay, so determine and interpret the interquartile range of the speed data. So your first quartile answer is 28 and your third quartile answer is 38. So put these values in the above formula. Interquartile range is equal to the Q3 minus Q1. So Q3 value is 38, then Q1 value is 28. So 38 minus 28 is equal to the 10. So the range of the middle 50% of the speed of cars traveling through the construction zone is 10 miles per hour. It means that the range of the middle 50%, interquartile range cover the spreadness of the middle values, 50% of the data. Interquartile range cover the spreadness of the 50% data. So your answer is 10. It show the range of the middle 50% of the spreadness of the data, which is 50% of the speed of cars traveling through the construction zone is 10 mile per hour. Your answer is 10. So it means that 50% of the speed of cars traveling through the construction zone is 10 mile per hour. So this is your comments. The number of vehicles sold by a major Toyota showroom in a day was recorded for 10 working days. The data is given as calculate quartile deviation and their coefficients. You have to calculate the quartile deviation, which is equal to the Q3 minus Q1 divided by 2, and their coefficient, which is equal to the Q3 minus Q1 divided by Q3 plus Q1 multiplied by 100. So you have to calculate first quartile and third quartile. First quartile is equal to the n plus 1 divided by 4 term. N is the total number of the observation, which is equal to the 10. Then 10 plus 1 divided by 4 term is equal to the 2.75 value. Second value plus 0.75. Third value minus second value in the given series. So second value is 10 and the third value is 15. Okay, put this value in the given formula. So your first quartile answer is 13.75. So third quartile is equal to the 3 multiplied by 2.75 term is equal to the 8.25 value. 8 term plus 0.25 multiplied by 9 term minus 8 term in the given series. So 8 term is 21 and the 9 term is 25. Put the value in the given formula. So your third quartile answer is 22. Now put this value in the quartile deviation formula is equal to the Q3 minus Q1 divided by 2, which is equal to the 4.125, and coefficient of quartile deviation is equal to the 23.08. So this is your quartile deviation and coefficient of quartile deviation.
So this is a part 1 of lecture 3. We will continue this lecture from here in part 2 of lecture 3. For next part of this lecture, please click the link in pinned comment or description and like, share, follow and subscribe this channel for more videos. Thanks for watching. See you soon. Till then, take care.